Here's 5 ways that I use Docker when I'm developing applications. These are techniques that I've come back to repeatedly over years of programming. Essentially, this video will show you my style of using Docker. I'm Alex, a data engineer, and here on Zazen Codes, I'm teaching full-stack data science. If you're interested in supporting the channel, you could check out my premium content on Patreon, and you can sign up for my newsletter. I send 1 email a week when I upload a new video. You can get all of the source code for this video on GitHub, so let's start by cloning that repository. I've got the repository here. I'm going to go to code, and I'll grab the HTTPS URL, and I'll just say git clone and paste that in. Once that's done downloading, you can go into the Zazen Codes YouTube folder, and inside of the source directory, you should see a directory called Docker Rapid Development Tricks. The first trick is spinning up a database on your system using Docker. So let's do that with Postgres and Redis. I'm going to go into the one folder for spinning up a database, and I'll open up a README file here. This is going to give us our commands, which we're going to run now. So how do we do this? I'll say docker run rm, and then I'm going to give it a name, which is my Redis, and I'm going to just say Redis. And what this is going to do is pull the latest Redis Docker image from Docker Hub onto our computer and then start Redis server. But I never specified a port mapping when I ran this, so we're not going to be able to access that Redis server. I can try and connect to this using the Redis CLI. I'm going to open up a new pane, and I'm going to say Redis CLI. And it's saying connection refused. There's no Redis instance found on this port 6379. So let's go down here and stop this. Now if I do docker ps, you'll see that nothing is here. It's been cleaned up for us. That's what that rm flag did. So let me go back to that, and I'm going to add a port mapping in. And what we want to do is map from this port on our computer to this port inside of the Docker container where Redis is running. So now that we have that port mapping in place, this is going to run instantly. We've already fetched the Docker image. It's just going to spin it up. By the way, if I go over to Docker Desktop, we can see this running here. We'll zoom in on it, and we can see the image that was pulled with the latest tag. And now over here, I'm going to try my Redis CLI command again. And I'll move this over, and I'll say Redis CLI like this. And now we're able to connect. And I can say keys star and list all of our keys. I could set a key. And then if I list them again, I can see that here, and I can get it. Now let's do the same thing for Postgres. I'm going to spin down my Redis instance. If I go over here and try and get stuff, there's going to be an error because Redis is no longer running on my computer. I'll exit out of that anyway, and we're going to instead run Postgres. We'll say docker run rm name my Postgres, and then I'm going to map the port 5432 from my computer to 5432 inside of the Docker container, and that's just the default port that Postgres is going to run on. Next, I need to set a password, and so I'm going to say my secret password, and this is going to set that as an environment variable. Then I'm just going to pull in the latest Postgres image like this, and that'll get Postgres running locally on our computer. Now if I go up here, I'm going to make this a bit bigger, and I'm going to try and connect to this. So I can say psql, this is the Postgres command line tool, and I'll say -h, and it's going to be the local host is where it's running. There's going to be a username, which is Postgres, and the database is also going to be Postgres. If I try to do that, it asks for a password, and my password was called my secret password. So now I'm in my database, and I could ask for what tables I have available, and there are none, but I could create one. So there's my table, and now if I look at that, I have that relation, and I could say insert into that. There we go. And I can select from that. Now that's pretty cool, but we did need access to these command line tools. So let me show you how you can use this type of thing with Python. I'm going to come down here, and I'm going to start our Redis backup again. That's how we did that. So now I have Redis and Postgres running. And if I go to Docker Desktop, I can see these images, but these images aren't actually necessarily running, although they say they're in use here. But if I go to my containers, I can see what's actually running. And these are the images, these instances of the images, and I have these both running. So I'll leave my Postgres here, and what I'm going to do is go into Python. Now I have a virtual environment here where I've installed some requirements. Here's my requirements file, and I just install these by saying venv bin pip install -r requirements like this. Now I'm going to go into that virtual environment and I'm going to run some Python code. And I've got a Postgres demo and a Redis demo. So let's do the Redis one first. I'll just import Redis and then I can connect to it using this code here. And now I can set some data. So I'm going to set foo to be bar, and then I can fetch the value of foo like this. And if I print that value, you can see it's bar, as expected. I can also decode that because if I look at the type of my value, it's a bytes type. So what I can do is decode that into a string type using this code here. Now let's demonstrate Postgres with Python. I'm actually going to shut down our Postgres Docker image here, and we're going to start it from scratch. That just wipes all the stuff we were doing before. Here's the command again to do that, and just see this Postgres password that we're setting to my secret password. We're going to use that soon. So now our database is back up, and we're going to open up a new instance of Python and go to the Postgres demo. And we're going to be using scicopg2 in order to query our data and use our database. And I have this chunk of code to connect to it. And notice we're using these default Postgres variables for the database name, for the user. But for our password, we're setting my secret password. And that's the environment variable that I set when I ran this Docker image. So now using this cursor object, I could execute some code. And I want to create a table called test. Now I'm going to insert some data into that table, and then I can say con.commit in order to write these things to our table. Now I'm going to grab that data, and I'm going to select everything from test, and I'll say cursor.fetch all. And you can see there's that one row for hello world, which we've inserted into our table. I could insert another row, and this one I'm going to say hello world again. Now I'll say con.commit to send that to the database, and I'll again select everything using our select query, and then I'll fetch all of that. And that's how to quickly spin up and use databases with Docker. And you can do this for all sorts of databases. Here are some of the most popular ones. There's also MySQL. You could run a Linux box, Debian, or MongoDB, or Zookeeper. Here's one that has Go installed, or Drupal. Here's one for WordPress. And if you wanted to run this, you could pretty much do it the same way that we just showed. Here's the one for WordPress. The next trick is to use Docker exec to go inside of containers which are running. So I've kept those containers running from the last example. And if I say Docker PS, I can see them, they're running right here. And pay attention to the names. The first one's my Postgres and the second one is my Redis. Let's start by connecting to the Redis one. I'm going to say Docker exec -it my Redis. Next, I need to specify what I want to run inside of that Docker container. And I want to run the redis CLI command. So I can do that like this, and now I can just start looking for my keys and getting them and using Redis CLI. But what I could also do is say the same thing, but instead of Redis CLI, I want to connect to bash. And now I'm just inside of that container. I go into this data folder by default, but I can see anything. And from inside of here, I could say Redis CLI, and I can do all the commands like I'd expect. So let's do the same thing for Postgres. I'll get out of Redis CLI inside of the container, and then I'll get out of the container altogether, but that's still running. Now let's go into Postgres. I'll say Docker exec it my Postgres psql-u Postgres. And here I can look at my relations, and I could say select everything from test, and this is going to be all of the data from the last screen. I could also do what you expect, like insert into test. And just like I showed you before, if I get out of here, what I could do instead is say bin bash. Before I just said bash, and that just gets me into here in a bash environment where I could say create files. And I could put data into those files. Here my file's called things, but then inside of here I could say psql-u Postgres. And then I could do the same thing that I was doing before. By the way, you can also do this with Docker Desktop, although I'd encourage you to use the command line as much as possible, especially with Docker. But if I go into here, say my Redis, and then I go into my exec, I can start doing my exec commands, and from here I could run my Redis CLI. Next trick is using volumes, and in particular, I want to show you how to use an app volume to share your app code. Using an app volume is a great technique for rapid development because instead of copying your data into the image and having to rebuild it every time, you're just sharing it with the container using a volume. In order to show you how that works, I've built a simple app. And what we're going to do is generate some data, then we're going to train a model, and then we're going to run that model. And I'm going to have volumes that are going to share data and artifacts in addition to the app code. That will all be done when running the Docker image. And here's what the Docker image looks like. I'm importing from Python 3.12, and then I'm installing pandas and scikit-learn, and I'm being careful to set the exact versions I want so that this will always work the same way. I'm setting Python bufferd, which is a Python trick or gotcha, and if you don't set this, you might not see output from your container. And lastly, I'm just running an HTTP server, and what this will do is keep the container alive after I run it. While it's alive, we're going to be going inside of it and running our app. So let's go back to our README, and I'm going to build this. I'll have to go into this 3 app volume folder where all of our code is, and I'll say docker build to simple ML app, and I'm going to say a dot for this Docker file right here. Now if I go to my Docker desktop and I look over in my images, I can see my simple ML app has been created, but it is unused. So let's run it. So I can say docker run --rm. This is just so that it removes it after it's done running. Then I'll say name, and I'll call it simple ML app 1, and I'll attach my volume. The first volume I want is from this folder right here, my app folder, and I want to share that inside of the container with just from the root directory app. So you can see what's happening with Docker is the common convention is we go from our machine into the container. So from the folder data into the container in the root folder data. And I'll have another one. The last one we're going to do is from artifacts into the container. Artifacts. Lastly, I'm just going to say simple ML app, and that's the name of my image. Now that that's running, we can see that it's serving on this port. And what that's doing is just running this command from my Docker file. We don't really care about that. All we care about is getting into this container and doing some stuff. So let's bring that over here, and I'll sort of bring this out a little bit. So this window here is just running my Docker container. And over here, I'm going to say Docker PS, and I can see that that's running, and I can see the name of it is simple ML app 1. So let's go into that. I'm going to say Docker exec it simple ML app 1, and then bash. Inside of here, I can see some folders. So I should see a folder here for data. I can see one for artifacts, and these are both empty. And then there's one for app, and that's not empty because app has all of my app code right here. It's shared this code, and I'm going to run this. And I'll go into app, and I'm going to say Python Python generate data. Now, pay attention here. If I open up a new pane and I go into 3, app volume, let's look at what we have going on here. If I look at a tree, I have no data in artifacts and no data in data. And now I'm going to create some of that from inside of my container. So if I run that, let's look at my tree again. Now I have some input data which has been created. And if I look inside my container, that data is also inside my container. So I can look at the head, what that kind of data looks like. It's this CSV file. It's kind of hard to tell what's going on from just in the terminal, so I could open up a Finder window and just make it really clear that this data is on my computer. But there's no artifacts yet. These are going to come when I create my model. So let's pop over to that code for train model. Okay, my window's got a little messed up here. Here's what I'm going to do. I'm loading this data. And notice the path I'm using. It's like an absolute path from data because that's how it looks on my Docker container. If I just look in data, that's where the input data is going to be. And then I'm going to train this model, and I'm going to save it to this artifacts folder. And again, this is like an absolute path on my Docker image, right? But it's different than the path in my system. Right, so let's run this, and I'm going to say train model. And if I go up here and I just bring this out a little bit and I look at my tree, now we're going to see that there's a model here. It's this binary file called linear regression model, and that'll also be in my Docker image. And just to remind you of the command that made all of this possible, it's this part right here where I'm sharing the app as a volume, the data as a volume, and the artifacts as a volume. Now, what's the power of using app as a volume in this way? Because that's like the main interesting thing I think that we're doing here. Well, let's go to run model, and this is what I'm going to do next. So we're going to take some command line arguments, and then I'm going to go ahead and load those and make a prediction with my model. So let's see how that works. I'm going to pop that back over to the right. By the way, I just realized I wasn't casting, so I'll do that now. Anyways, here's my Docker container inside here, and I'm going to run this code to get some predictions. So I'll say Python run model, and let's just see what happens. Okay, so I have to pass two arguments, x1 and x2. Let's do 23 and 389, and here's my prediction. It's outputting -82. So this code's running fine, it's doing some cool stuff, but now what I can do, because I've shared this as a volume, I can actually edit this code directly right in here on my system. Let's say what I actually wanted to do is take like x2 and add like 100 to it. So I could do that just like this. So if I run the same thing, it's going to immediately see that difference. And here I'm just adding 100 to x2 as an example. So now if we wanted to go ahead and package this, what we could do down here, copy app to app inside of my image. Now I'll just go ahead and close this out. Now I could go ahead and build it, and I'll stop it from running. Now let's get this running again, but I don't want to share app as a volume anymore because I've actually put that directly into the code. Let's check that that's running. Now I'm going to go back into it. And if I look at my app code, this data has been baked right in here. So let's go in here, and again, I'm going to say run model. I'll pass a couple values here. It's doing all this logic. It's adding 100 just like we made that change. Let's say we just didn't want to do that. I don't want to add 100 anymore. So I just changed my code locally. But you know what's going to happen, right? It did not reflect that change. If I wanted to reflect that change, I would have to rebuild it, which means I would have to get out of this, I would have to close it down, rebuild it, bring it back up, and then rerun this again over here. And this is the power of using volumes for your app code. Next, I'm going to talk about using environment variables. Being comfortable using environment variables is really helpful to quickly set configurations or pass data into your Docker image like an environment variable, for example. Actually, I misspoke a little bit there. We don't really think about environment variables as being known to the Docker image. They're not like packaged up and included in the image itself. They're more like provided to the image at runtime, because a container is a runtime instance of a Docker image. I talk more about these introductory topics with Docker in a video I have on Docker runtime arguments, which you could check out if you're getting started. I talk about environment variables in that video as well, but here I've got a simple example to demonstrate the utility of environment variables. And I've got a simple Docker app here. It looks very similar to the last one. We have Python 3.12. We're defining a working directory, and then inside of that working directory, down here on line 7, we're copying data from our computer into the container in that app folder, and I'll show you what that looks like. And I'm also installing a library that I need, scikit-learn 1.5.1, being careful to set that version. So the way this app works is that when I run this, it'll just run this train model, print any output, and then close. And here's that train model code right here. What's interesting and relevant for this part of the video is how I'm getting environment variables for a random seed and this regularization strength C. And then I'm providing those values into my model using that in my code. If you're curious about this syntax here, what it's saying is that it's saying get the random seed environment variable, and it's conventional to use uppercase letters for environment variables. And if that's not available, just use 0 as the default. Likewise, if the regularization strength is not set, then just use 1 as the default. Okay, so I've got a little split tab going. I'm going to go to my README, and we're going to build this. And I'll say Docker build 2, and I'm going to name it something. I'll call it Iris Logistic Demo, and I'm going to build the thing right here. Now, I actually am not in the right folder, so this is not going to work. But if I go to for env variables, this is where my Docker file lives, so I can run that command here and build it. If I actually list my Docker images, I can see that here. It's called Iris Logistic Demo. Now I can run this, and I'll say Docker run rme, and this is how I define an environment variable. The first one I want to do is a random seed, and I'm going to say 137. And let's just try setting only that one. I'm going to say Iris Logistic Demo. And here we can see that the code is running. It's setting our random seed, and it's using that default regularization strength. What I could do is set that in this way, C reg strength. And let's try setting that to a really high one. I'll say 9. And here you can see the code's picked that up. And now we're getting slightly different scores coming out. Actually, you might notice I'm not printing the score here. Let's change that. And as we talked about before, this is not actually going to update. I have to go ahead and rebuild this. So I'll rebuild it. And now if I run it again, we'll actually be getting our score out now. And lastly, being comfortable with environment variables also means being able to use .m files. So I have a .n file right here, and I'll open it up over here. And this, I could just say set some environment variables in this way. Now if I want to set all of these .m file variables to my environment when I'm running my Docker image, I'll say docker run, and I'll say env file equals .env, and then I'll pass the name of my image. And you can see now it's setting 27 and 0.05, which is defined in my environment variables file up here. And I can change this without needing to rebuild my image. To demonstrate that, I'll just set this to something like 491. And also, how you would typically want to use a .n file like this is to set a password. For example, if you had some API key, you could set that in here, and then that would be hidden, and you would make sure not to commit this n file to version control. So to demonstrate that I don't need to rebuild anything, I'll just rerun the same command as before. Now it's setting the random seed as that new number, which I set up there. And that brings us to the final trick or technique, which is using Docker Compose. Compose is useful for doing two things. I like it because it simplifies the process of running the Docker application. You don't need to be so careful with passing all of these things into a Docker run command, because that basically gets baked into the Compose file. Here I have a Compose file, which includes a web application. It includes a database, Postgres, and it includes a Redis database as well. And the idea is that our web service needs access to this Postgres database and this Redis image. So let's package it all together into one file. And when I run this Docker Compose application, it's going to start all of these services, and it's going to do it in the right order. For my web service, it depends on the database and it depends on Redis. So this is not going to be available for us until these things are available. I also have shared parts between these. For example, the Postgres password needs to be known by my database, but I also need to know the Postgres password in my service so that I can use the Postgres database with my prediction server. I also want to use the same .n file because that Postgres password is being loaded from an environment variable called Postgres password. I'll show you what that looks like right here. This is just defined in my .env file. And in order to understand what's happening here, the first thing you need to do is look at this app. So I'll open up the app, and I've got this simple prediction server. And this is just a Flask application. It's going to go ahead and make some predictions, and then it's going to upload those predictions to Redis and to Postgres. At the bottom of my file here is where I'm actually running this server. And this is what's going to run when I run my Docker service. Let's open up the Docker file. And this runs that prediction server. So this will start that Flask server, which I was just showing you. But how does this Docker file connect to the Docker Compose? If I go back to Docker Compose here, I'm building from the Docker file that's right here in this directory. And I'm calling it a prediction server. So when I bring all my services up, it's going to go ahead and do that build for me. You'll see that this Docker image gets created, and then it's also going to run it. And in addition, it's going to make sure that Redis is running, and it's going to make sure that Postgres is running. Now, if I look at Docker PS, I've already got Redis and Postgres running, so I'm going to bring those down. I'll say docker stop my Postgres and docker stop my Redis. And if I do docker PSA, then I shouldn't be able to see those. They've been cleaned up, they've been removed, so they're no longer going to interfere with what I'm about to run here. This ML app shouldn't interfere either, so I'm just going to keep that running. I'll go into the folder for this. And let's look at everything we have. I do have a file in this artifacts that's going to be used by the prediction server. But otherwise, when I run this, all it should do is start my prediction server for me. And in order to run this, I just have to say docker compose up build. Now it's running the Postgres database, the Redis database, and it's also running my server. And I can say docker ps, and I can see all of those things. Looks like my prediction server exited, which is unexpected. So let's see if I can figure that out. I'm going to ask for the Docker logs of just that one service. I'll zoom in on this so you can see what I'm talking about. It was called 5 compose. That was the name of the folder I was in. And then it called it web1 because I'm using the web service and this is the first of it. You could scale and have multiple services running with Docker compose. And I can see the logs from that. And it wasn't able to connect. It didn't find any database running at the appropriate port. It wasn't able to find Postgres. So strangely, what seems to be happening is that even though I've set this depends on DB and Redis, it wasn't available in time. Let's look into that further. So I'm just going to scroll up a little bit in my terminal and look at the logs. So you can see here, Redis boots up right away, and it's pretty much ready to accept connections. And then Postgres starts running, but it's not actually ready yet when our web service tries to start. And so when we try to connect to Postgres, it's not available yet. It's not actually until after we attempted that connection that we can come down here and say, okay, success, you can now use the database. So because of that, we weren't able to run it. So what we could do is just bring up this one service separately. It's a little bit awkward, and my windows are a bit messed up. Okay, so down here, I'm going to go into 5 compose, and I can say docker compose, and then I'll just say up and web. And now it was able to start successfully. So let's start talking to our web server. Down here, I have a command to make a prediction using curl. I'm going to open up yet another window, and this could be anywhere on my computer. I'm just using curl. I'll go to my downloads and I can say curl localhost, and it's running on port 5001. How do I know it's running on that port? Well, if I go up here and I go to my Docker compose file and I scroll up a little bit, that's the port that I'm sharing from inside my computer, port 5001, to inside the Docker container, port 5001. And we can continue following that trail. If we look at the prediction server, we can also see that port at the very bottom where I'm actually running my app. I'm running it on port 5001. And next what I want to do is call this predict method. Right here, it's a post route and it's called predict. So I'll say predict, I'll say x post, and then I need to make sure I'm setting my header, content type, application JSON, and then lastly I can pass some data, and we need an x1 in here, some number, and we need an x2 in here, some other number. And when I call that, I get my prediction back, which is -19. Now our application is doing a bit more. Let me zoom in on it. After we get our prediction and we do print that, or rather we return it, I'm also inserting that into a Postgres database, and I'm also setting that in Redis. I could use some of my old tricks. I could say docker exec into, and we're going to go into, let's say, the Redis one, and I'll just go into the Redis CLI in there, and I can say keys star, and I should be able to see last prediction, and I can get that. And it was like -19, and that's the value right here. Let's do the same thing with Postgres, but just to switch it up, I'll go to my Docker desktop. In my containers, you can see this stack of services, which is from my Docker compose, and I'm going to go into my DB1, which is my Postgres database. Inside of exec, I can say psql.u Postgres. I can look at my tables, and indeed I do have this predictions table, and let's select star from predictions. And here it is, -19. Cool, so now let's bring all this stuff down. I'm going to go back to where I was in my 5 compose folder. This is where my Docker compose lives. From here, I can say docker compose down, and it's going to bring all of these services down. So you can see this one stopped running. Over here, it seems to be still running. Let me see. Nope, it's definitely down. I can see that that Docker compose app did come down, and so we're all cleaned up. I don't know about you, but that one made my head hurt. I hope you were able to follow along and understand when we were in the Docker container and when we were on our local system, and how we were passing data in between those two places. I hope these tricks help you with your development, and if you want to support the channel, please give this video a like and consider subscribing. And you can also check out my premium content over on Patreon, which is focused on full stack data science. You can sign up for my newsletter, which is another great way to support the channel. So over to you. I hope you're able to put these techniques into practice when you write Docker applications. And this is pretty much how I use Docker. So if you think there's a place that I could improve my processes, please let me know in the comments below. Thank you for watching, and namaste.